Okay. So actually, I think we can get started if you don't mind, and the people will join in next minutes. Actually, we have 2 minutes, but I think we can start. Let me screen my share. Let me share my screen. I'm very sorry.
No problem.
Okay. I hope you see my screen, right? So
yes, you can.
let me make item. Sorry, once again, let me make item co-host. Okay. Right. So welcome everybody. I'm very happy to see you again here after 3 weeks. So as always, I'm beginning one of the beautiful ways of Baku, City of Winds. So actually, today we are going to have our Baku Power BI and Modern Excel user meetup groups 14th session. And today's speaker is Claudia Buckley from Canada, whom I knew from goskills.com educational platform. And I participated in one of her courses there, and I enjoyed this course. So Claudia Buckley is going to deliver a speech about new dynamic array functions and also let and lambda functions. And I strongly believe that you will enjoy this session. Actually, busy schedule, busy weeks are waiting for us. And in next week, we are going to have Pragati Jain from United Kingdom, who is going to deliver a speech about conditional formatting in Power BI, which is going to take place on September 17th, on Friday. After Pragati Jain, Mr. Oakley Turvey is going to be our speaker, who is going to talk about understanding data visualization, aggregations, and filters. So if you have any question, of course, you may ask during the session, or you may write on your chat box. And I believe that you will enjoy this session. Once again, thank you for your attendance. And I believe that we are going to meet with you on, next week on September 17th. So I'm going to stop sharing my screen, and the stage is yours, Claudia Buckley. You may share your screen and go on, please.
Okay.
Good luck.
Thank you. All right, so thank you very much, Ildar, for the intro. And I'm not going to spend too long talking about myself. Today, we are going to talk about the dynamic array formulas in Excel and generally dynamic arrays. And these two new functions, well, relatively new anyway, let and lambda. If you need to reach out to me for anything after this session, then here are my contact details. Most people contact me via LinkedIn. I also recently joined Twitter, so if you want to contact me there, that's fine too. My expertise is mainly in Microsoft Excel, but I have many interests, and I don't have a favorite. It just so happens that I'm talking about Excel today, but in my career, I've done workforce management, performance management, focused a lot on aviation software training, customer service, telephone sales, and I also do quite a bit of writing. I also have a business writing training course. So I freely speak about any of these or write about any of these areas. But enough about me. Today we're really here to talk about mainly dynamic array formulas. And many of you have been using dynamic arrays for a little while since Excel rolled this out in 2018 for their Microsoft 365 version. And for those of you who don't use it or not quite clear on what dynamic arrays are, this is the way that formulas are now able to spill values by returning multiple values from a source array. So initially, the way we know formulas work is that, of course, you enter a formula in a cell and you get a single output. But now there is this change in the way formulas behave, in that we're now able to spill multiple values by entering only one formula. And it offers a number of advantages, which we're going to see in our live demo today. We'll see that the results in the output cells will update. If the source data expands or contracts, then the output will expand or contract with the source data. What this means is that it eliminates the need for the legacy CSE entries. So you know how we'd enter ctrl+shift+enter to get a large output, a spill, sort of an output. Well, that's eliminated now that we have dynamic array formulas. And the implication is that it reduces the need to copy and paste formulas the way we were used to. Now, many people don't see this as a big deal. For me, it is, because sometimes you're dealing with a large array and you don't want to have to copy and all the way to the end of the row sort of thing all the time. So if you have dynamic array formulas, it means that formulas that were initially only single output formulas can now potentially give you a spill. And we'll see a demo of that too. Okay. The caveats, the things to bear in mind are that, of course, it's only available with Excel 365. We don't imagine that Excel will be doing backward compatibility for this. If you are working within an Excel table, you will not be able to use dynamic arrays. Okay, and we'll see, I'll show you what happens if you try to do that too. You might have already noticed, if you've tried to work with dynamic array formulas, is that if the output area, if the area that Excel wants to spill to has any obstruction, any value within any point of the array, you will not actually get the result. Instead, Excel will show you a spill error. And once you do have that output, when you go to a cell that has been spilled, the results will be ghosted, meaning you'll see the formula grayed out, but you won't be able to edit that formula unless you go to the very first cell, the one where you enter the formula itself. So those are the only few things to bear in mind, the major things to bear in mind when you're working with dynamic array formulas. So Excel created a few functions with built-in spill behavior. And these are what we call now, I guess we're going to be referring to these as the new functions. For now, in this session, we'll refer to them as these new functions. And that's the filter function, rand array, sequence, sort, sort by, unique, XLOOKUP, and XMatch. And I'm pretty sure that most people on this call have used one or more, maybe all of these functions at some point in time. If you haven't, well, we'll get to see how we can use them and how we can sort of use them to solve extra problems when we nest them with each other. Of course, the two new functions that have gotten people pretty excited, let, which has been around since 365. So with the let function, you can declare up to 126 variables and use that within that formula in which you declare those values. These work fine with Excel tables. So unlike the dynamic array formulas, which don't work within a table, the let function does work within Excel tables. And of course, Lambda. Lambda has changed the game for many people because you don't need to be a programmer to write your own function. And that function can be used anywhere within the workbook in which it's defined. Lambda also works fine in Excel tables. with dynamic array comes the spill range operator, that's the hash sign. What the spill range operator does, it's used after the first cell reference if you want to refer to an output where a dynamic array range began. So as an example, if I enter B10 and the hash sign, that means I want Excel to display the entire output range, because in cell B10, it means that in cell B10, there was a dynamic formula entered there. And now I want to refer to the entire output range. And finally, the @ sign, the implicit intersection operator. What this does, well, let's give a little history. The implicit intersection operator was used in legacy Excel, but it was just in the background. We weren't seeing it the whole time. Now we'll be able to use it to our advantage. What the @ sign does is to force a single value output when a dynamic array is referenced. So now for those of us who are using Excel 365 with dynamic arrays, there's some formulas, functions, which we mentioned earlier, which default to a dynamic output. But you may on occasion want a single value output, and you can use the @ sign to do that. You may be accustomed to the @ sign when you were working with Excel tables in the past. And what it usually meant was that it's this row. So if you put that @ sign, it meant this row. I'm only referring to this row. The concept is the same here. So if I use the @ sign, it means I'm just referring to this row or the corresponding row to this cell. I know right now it seems like I'm not sure what this means, but we'll do an example. And of course, this presentation will be available to you later so that you can go it over on your own. If you open a workbook that was created in an older version of Excel, you may see the @ sign, because those would have only given you that single output, because the older versions of Excel don't have the dynamic array functionality. All right, so now it's time for us to jump into the actual demo. And before we jump in, I just want to explain the example that we're using. So for most of my career, I've been in aviation, in almost every department in aviation. So call centers, human resources, flight operations, everywhere. But I think the area that probably captures the most data is call centers. So I think that's a really good place to demonstrate all these functions. So that's where we're going to jump in with this example. All right, so on this worksheet, what I have is a training database. So the background is in our call center, that we're our imaginary call center, airline call center, we have all these agents that are on the phones in the call center. And we offer these courses that are in row 1. All right, so typically agents start out by learning telephone sales, and depending on how the airline, depending on their model, agents might just be trained in a single area first, and then as they get to more seniority, they get the opportunity to cross-train in other areas, because everyone's first ambition in a call center is to get off the phones, or to at least have some job diversity. So everyone will typically be trained in telephone sales. So here we have a total of 85 agents, and everyone is trained in telephone sales. But then as we go on to more advanced skills, then we have fewer and fewer agents being trained. So this is our database, which typically would be maintained by maybe the HR or the admin of the department, of the call center. So this becomes our database from which this entire workbook will pull values and will get data and information. So the first thing we might want to find out if we're the admin of this call center is the courses themselves. What courses are taught? And here we have the courses that are taught. So the first thing that I did was to enter these as explicit values. These are the course names. And maybe we want to know how many people are trained from each course. For those of you who haven't yet tried to use XLOOKUP, I'll start with XLOOKUP because it's one of the easiest ones to understand how it works. XLOOKUP is kind of a replacement for VLOOKUP and HLOOKUP because it refers to each array that you want returned. So here's the formula and the syntax of the XLOOKUP function. We need the value that we're looking up. So in this case, we're looking up the name of this course. The lookup array is where we want to look. So in this case, we want to look back here in the training database.
Claudia, sorry for interrupting you. People
Sure.
are asking to make it a little bit larger.
A little
Please.
bigger? Okay.
Yes,
No
bigger,
worries.
please. Thank you.
Sure. All right. How's that? Is that better?
Yeah, that looks okay. You can
Perfect.
carry it, Claudia. Perfect.
All right. So now we have we're looking up the course name, and where we'll look up is, of course, in our table. So this training database, I'll just hop back over. I gave it a name. It's an Excel table. So the name of this table is database. All right, so that I can use this to refer to that range much more easily than having to remember the range name, the cell references rather. All right, so here I'm looking up values that are in the database. I'll look in all the headers. So Excel created this for me. And the return array, this means what values do I actually want to return? If I don't find the values here, then I can customize my message to say, okay, this course isn't in the database. And do I want an exact match? So here's the match mode options. 0 is for an exact match, -1, 1, and 2. These are the other options available. However, I didn't use that option because it defaults to an exact match. So it means that if I type something that didn't exist, let's say I type telephone sale, well, that doesn't exist. So then my if not found is the value that's returned, okay? So that's also, an improvement over VLOOKUP or XLOOKUP where it would return an NA error, which an end user might not know exactly what that means. So we'll go back to telephone sales, which is the name of the course. So I'm going to just delete what's here so that we'll work on it together. So we type XLOOKUP. The lookup value is the telephone sales course name. The lookup array is going to be the database table. And the column will be, well, let's look up the entire area, all right? So it's much easier for me to just grab here, the headers, all right? So that's where we want it to look up. And if we do find it, what we want to return is, let's go back here. Okay, so what we're looking for is the number of people trained. I'm sorry, I forgot what I was looking for. So here we go. We're looking up this value in the headers. And what we do want to find is the number of people trained here. So what the XLOOKUP function does is to match. So if it finds the name of that course, it'll say, okay, give me the total that's trained. And if not found is our next argument. If we don't find the name of that course, we want to say course not found. and that's in double quotes because it's a text value. And the other elements are all the default values. So I don't need to enter them because the match mode, we want an exact match. And for the search mode, we want the default, which is from top to bottom. So we close parentheses here, and that's how we get the 85. So now we know all the courses that are taught and how many people have been trained in each course, because we can just copy this all the way to the end. Now, what if we wanted to find out the top 5 courses? So this call center offers 10 courses. And what are the top 5 areas in which agents have been trained? We can use one of our dynamic formulas to get that. So typically we use sort and filter together to get this done. The filter function, I'll just get over here and type the syntax of the filter function for you. So the filter function typically needs a minimum of 2 arguments and an optional argument of if empty. What it does is to say, okay, the first argument is what's the array that you want to filter? And the second argument is what do you want to include? What should be in this filter? The third argument, if empty, means if I come across an empty cell, what should I do? Should I ignore it? Or should I also display that empty value? Sorry about that. All right, so what we did here was to say, we started by filtering the array. What array? The courses. So this table, the one here that we created, this is a table that's called courses. So what I did was to filter by the courses, filter this array called courses, and then the next argument is what to include. Because I want the top 5 courses that our agents are trained in, I say, okay, filter by this column, that's column B, courses and the number trained. And how do I want to filter? I want any value that's greater than or equal to the largest 5 numbers. So basically, we've also nested the large function into the filter function. So we've said, okay, grab the largest 5. Here's the number 5. And then we continue with our filter function to say, how do we want it sorted? We want it sorted by the third column. So the third column of our table, okay? And this asks for the sort order. The order should be in reverse order. So if we had, here are the options. 1 is ascending order and -1 is descending. If we omit that, the default is ascending. So we want that in descending because we want the larger number to show up first. And that's how we got this value here. So that's how we have the top 5 courses in which agents have been trained. All right, we've got a lot to cover. So I'm going to hop over to our sequence function. What sequence does is to create a sequence of numbers starting where we want and telling Excel how many rows, how many columns we want in our sequence and what step value. In other words, how much to increase the sequence by. So here's what the sequence function looks like. We need rows as a required argument. But columns, start, and step have default values. So those are optional. If we don't enter those values, Excel will assume that you only want 1 column, you want to start at the number 1, and you want a step value, or you want to increase your numbers by 1 each time. In our formula here, what we're trying to get is a staff meeting schedule. So let's say in our call center, we have 6 managers, and we want them to host the staff meetings for the remainder of the year or for the entire year. So hypothetically, let's say our first meeting date is going to be on January 6th, and our staff meetings are held every 6 weeks. So this is how we create this formula. So let me just delete what I have in here and create our formula to say sequence. Right, just a sec here. Okay, great. So for the sequence function, we get in here and say, how many rows do we need? We need 2 rows. I know that off the bat. How many columns? Because it's not 1 column, we have 6 managers. So I'm going to say 6. And we want to start with the January 6th date. So I need to nest the date function in here, and it's the year 2022, the first month and the 6th day. That's where we want to start. And the step value will be how much do I want to increase it by? So every 6 weeks, that's 6 times 7, 42, 42 days each time. And that's how we end up with these values. You may be wondering how come there's no values in here. I just changed that because this ends up being in the following year, 2023. So I can say, okay, my schedule ends in December of this year. So I can simply remove that. And if I didn't want anyone to see my formula, of course, I can just protect, hide the formula, and maybe even protect the sheet. All right. So people won't be able to see the formula if I really wanted to go that way. All right. Not that it matters. So the sequence function is pretty easy to understand, and you'll see in another sheet how we can use sequence to do even more exciting stuff, like this one. So pretty often for agents to get their schedule, so every call center uses different methods, but the most common method is to use a bidding system where agents get to bid for the rosters that are available. Some call centers use a random system. So every week or every month or however often the schedules are put out, then agents get to bid in some kind of order. So who goes first to select their schedule? Many call centers use a performance-based system, but some use a random system. So that's pretty interesting. And that's the demo we're going to use today. So we have all the agents' names here. And we can use our a combination of our dynamic functions to decide. Now, my first inclination was to just use rand array. So let's see what happens if you use rand array. We want to know how many rows. We could go all the way down to count how many rows, but there's also another way of doing it. We could just say, okay, use count A. Can everyone see the screen? Or do you need it larger than this? Or is it good? I'm going to assume it's okay. All right, so let's say we're using count A, and we want all the values that are in, we want to count every row that has a value with the exception of the header row. So I'll -1 here, okay? So that's the number of rows that I want a number to be generated for. How many columns? Only 1, that's the default value. So I can type 1 or I can omit it. The minimum value that I want is the number 1 because I want it to show who the first person will be. And the maximum value will again be whatever number we came up with here, +1. And we do want only integers. We don't want any decimals, so I type true here. So this was my first inclination, and it looked great, except that there are duplicates, okay? So we don't want duplicates. The only way around that is to then combine the sequence function with the sort by. So here's the rand array that we typed, all right? But here's how we really make this work for us in generating a random list that has no duplicates. It's completely unique. So we remember what we did with sequence was to, we can create step values here. So if we want to say, I want to create a sequence of numbers that's equal to the number of values here. So we use count A, the column -1, values in the column -1. Then that becomes the first argument of our sort by. Because now, once we've created this sequence, then we can say, okay, I want to sort this particular sequence by a random array. And so I thought that was pretty cool. If you are in doubt as to whether there are any duplicates here, you can always run a conditional formatting to find duplicate values, and there are none. Okay, whereas with our other formula, if we just selected rand array, let's just copy from here. It's easier, I think. If we were to just copy rand array and try to find duplicates here, I need to highlight everything. I don't know the Mac shortcut. I'm sorry, I don't use Mac that much. For those people who will hate me because of this, it's true. All right, so if we only use rand array, then we'd end up with a bunch of duplicates, and we don't want that. So that's why we nested it with these values, with these formulas. Now, because rand array is a volatile function, what you would need to do here is to copy these if you didn't want them to change every single time you open this file. So you just want to go in, copy, and you can always paste it as values here. And then you'd have these values static, okay? But it would be useful for generating a unique list of random numbers. All right, so let's press on. We're down to let. What does let do? It allows you to create or to declare, really, to declare variables for use in a particular formula when these variables will be used repeatedly during that formula. If you are accustomed to writing complex formulas, this will be very handy for you, because then you'll get to not have to repeat a value or a calculation that you'll use over and over in the same formula. So for this one, let's say this is the agent's quality scorecard. So for call centers, this is a very common thing. There's quality assurance where you listen to the agent's calls to make sure that the standards, the customer service standards are maintained. So let me just increase the size of this for those who might want it a little bit bigger, right? And so this is a call quality scorecard. Now, this should tell you that I'm very old school. So I'm from the days when there weren't that many applications and software to help you to do all this stuff. We're quite used to doing this manually and building this from the ground up in Excel. So our call quality scorecard might look something like this, but in each area, the scorecard is weighted differently for each area. So a call could have any of these elements, but they're not equally. All right, so I'm just going to mute someone. I'm not sure who it is. Oh, I see. Okay, great. Thank you. Yeah, so they're all weighted differently. So for greeting and introduction, we only weight that as 10% of the call. Contact handling, 5%. Sales is obviously weighted very heavily as 30%, and customer service, again, weighted at 30%. And potentially everything here adds up to 100, but not all elements are created equal, right? So in ensuring that however the agent scores, it's equal to the output of what they'll get overall, then we need to create a formula that does that. So here's how we did it with our let. let me just make this a little bit easier to see. I hope you can see this because it's quite small. If it's not, let me know and I'll try to adjust it for you. So how let works is, first you declare all the names that you'll be using. So anything that you want to consider, it's like a shortcut. So I realized that in creating this weighted, these weighted percentages, that we'll constantly want to count how many values are here, because everything is going to be calculated as a factor of the number of values that the agents could score on. So if the agent did everything here, then they'd automatically get 10%. But if the agent didn't do something, then it should reduce it by one of the 4 factors here, and so on. So for each section, so this is 4 factors, greeting and introduction, but this one is 3, and this one is 3 and 3, 6. So what we need is a count of each section. So what I decided to do was to declare this value as, to declare this amount as values. So what we've said is, okay, let the word values be equal to this calculation. And that's the only variable I declared for this formula. So that each time that I want to type count A, D8 to D18, then I would just type the word values instead. And so this works only for this particular formula. In the next section, I declare values as D13 to D15, so this area, and so on. And for here, D29 to D34, so that in the calculation that I'm asking Excel to do, instead of having to type count A, D8 to D11, each time I replace that with the word values. And that's how the let formula works. Important to know for let is that the calculation that you do should be the final thing. So declare all your values and their meaning first, and then the final thing you do is the actual calculation. All right, Lambda. So as we mentioned at the outset, Lambda is only available in Excel 365, of course, but only if you're in the insider channel. But what Lambda does is to make people like me, who aren't programmers, able to define their own functions within Excel that can be used anywhere throughout the workbook in which they've created it. So this is a really simple sheet to understand. We have here all our agents in our call center, the team that they're on, and their attendance, their call quality, and their daily sales. So let's say these numbers came in from somewhere else, some other software that we have, but we want to use these numbers to determine if agents get this weekly or monthly or whatever frequency. We have an incentive. And here are the rules of the incentive. It says that if the agent scores 95 to 100% on attendance, they get 1 point. If their attendance is below, then no points. And for call quality, if it's 100, 2 points. If the call quality is in the 90s, they get 1 point. If it's less than 90%, then no points. And they need at least 2 daily sales to get 2 points in sales. If it's 1 sale or less than 2, then they get a point. For less than 1 sale per day, then they get no points. And that's how we award their bonus. So I don't think I typed this here, but their bonus is if they have 4 points, then they'll get a $50 incentive. And if they get 5 points, then they get a $100 incentive. So that's pretty easy to understand, but the calculation of the incentive points could be a really long formula. So here's how Lambda works. All right. with Lambda, you declare what the names of the arguments are. So remember, in functions, we're quite accustomed to having to enter arguments with a syntax, with a particular syntax. So you are declaring what your syntax will be. So you name the arguments as you like, and you list them all at the outset. So for this particular one, we named them, we needed 3 items to calculate the incentive point. So the 3 items were attendance, quality, and sales. Okay. And then once we've declared that, then we go into how Lambda is supposed to calculate these incentive points. So instead of reinventing the wheel, I'll go in here and I'll show you how it's done. So I'm just going to get into my name manager and let me just copy instead of having to type this all over again. All right, of course we get a calc error here because Excel doesn't know what it is yet. But first I'll show you. So we typed attendance, quality, and sales, and then we say to Excel, this is how I want you to arrive at the calculation when someone enters the figures for attendance, quality, and sales. We want you to do this. You know, if the attendance is so-and-so, then they get 1 point. If it isn't, and so on, exactly as we outline in the points awarded data set. When that's done, then you close your parenthesis on the Lambda. While you're entering, while you're building your Lambda, you can also test to see if it will work. So how you do that test is you open parenthesis here and you say, okay, let me substitute values. So let's pretend that this would be my attendance that someone would type in. Okay, this would be the sales, and this would be, I'm sorry, the second one would be quality and the third would be sales. All right. For those of you who are really observant, you'll notice that @ sign here, if you didn't notice before, which is the same implicit intersection operator that we spoke about earlier. This is telling Excel that in a table, we're talking about this same row. All right, and now we need to close the parenthesis on this test that we're doing. And we'll say, okay, this person got 5 points, which is right because that's what we got here. Once you create that, okay, let me put that back in. So how you go about building this is, once you're satisfied that it works, then you just need to copy the formula that you wrote, not the test, just the formula you wrote, copy, and then you go into formulas, define name, and you can name your formula here. Okay. So in my case, I named my formula points. The scope is the entire workbook. And then you just paste what you copied here, paste that calculation. Usually what I choose to do also, because this is brand new, I feel like Excel might do more to upgrade this formula in years to come, but not right now, is I also put as my comment, the format of the formula. So I have what the 3 arguments are, because otherwise it doesn't tell you. So if I start typing points here, it doesn't really tell you what the format is. So you wouldn't know, or you wouldn't remember what format you need to enter. So I usually, and I'll show you in the last element we have, the last example, what I do to ensure that I remember the arguments. All right, but that's how the points, that's how Lambda really works. All right, last one. So let's say after all that's done, your admin, your office administrator needs to get a handle of everything. What are the training statistics? What are your team incentive statistics, and so on. So here's how we can use so many of these functions in a really useful way. So notice that at no point throughout all these worksheets did we list what the names of the teams were. All we had was in the training database, we had 85 agents listed, the name of the team that they're on in column B, but nowhere did we have the unique names of the team. So of course we can do that here. We use the unique function to say, okay, grab this array, which is from the database table, grab all the team names, and we want the unique values. We don't need by column because really there's only one. So we could have omitted the false argument here because there's only one column, so it doesn't matter. And this one that says exactly once, this is a really cool feature of the unique function. The programmers realized that the word unique can be understood in two ways. It could mean just take all the values one time. I don't need any duplicates. That's one way to understand the word unique. Or unique could mean only display values that appear one time. Anything that appears more than once should not be considered unique. So do you mean distinct values, or do you mean only once, values that appear only once? So in this case, we don't mean values that appear only once. We mean take all the distinct values. So that's why I typed the word false here, because it's not exactly once. And that ends our unique values. But I also want them sorted alphabetically. So that's why I wrapped the sort function around that. And I said, okay, so once we've got this array, then I want it sorted by the first column, which doesn't matter because there is only one column. So I could have removed that. And what's the sort order? It's ascending value, it's ascending order rather, which doesn't matter again because that's the default. I could have removed that too. And by column, that doesn't really matter either. So I could have ended everything right there, just at the end of unique. So let's do that and see what happens, okay? All right, and the results are the same. So I have all the teams here. Only the 6 teams, and they are sorted alphabetically. Here is something that we talked about briefly, which is that spill operator. Okay, so that hash, what it does, we explained earlier, is to use the spilled results of a dynamic array formula so that it treats the entire thing as a dynamic array. So the countif function, everyone knows how the countif function works. It uses two arguments, the range and the criteria. And typically, we either hard code the criteria or we use a cell reference. Here, what we're able to do, because we're using the database team name, so we say, okay, we want to know how many people are in each team, how many agents are in each team. So we say, okay, I want to count. Let me just, I'm sorry. Let's expand this again. Let's delete. All right. And we say, all right, let's count if here, that's from the database. And we want the team names. And what's our criteria? The criteria will be the name here in A3, but we want that to spill to everything all the way to A8. So I can just say, well, this was a spilled array, so I can enter my number sign here. Notice that it highlights all the way to the Vega team. I can close parentheses here, and then it's filled. So it makes even the non-dynamic formulas behave dynamically. Here's another example of how we can use Lambda. If you look in column M, from M3 to M8, you'll see a formula that I typed in, which gives me a skill set ratio. So what we want to find out here with the skill set ratio is that each team, we have the number of people that's in each team and all the number of people that were trained from that team in the different courses. As I mentioned before, everyone's aim in a call center is to get off the phone. So of course, people want to be trained in other areas, and their team leads also want them to be trained in other areas because they can use them to help out when, you know, something happens, someone goes on leave or whatever. So you might want to know what the skill set ratio is of your team. So in this team, let's take the first one, Capella. They have a skill set ratio of 69 to 31, meaning about 69% of the potential for cross-training has been achieved. Ideally, we'd like to see 100, right? 100 to 0. But here we have 69 to 31. And the way to calculate this is to do this really, you know, fairly complex formula to say, okay, find the number of people that have been trained here, get that total, divide it by the number of people in the team, and so on. But I could have just used Lambda. Okay, so this is how I use Lambda. I created a function called team trained, and I said I need these values. So that's all the people that were trained. The 16 people on the team multiplied by all the areas in which they could have been trained. And I only need those three values. So the range from C3 to L3, the range from C2 to L2, and B3. And I created that with Lambda. And like I showed you, like I mentioned before, what I like to do is when I'm creating, so let's say the name of this function was team train. Unfortunately, it doesn't show up on Mac, but on Windows. So here's what I did. Let's go to the name manager. And I created a comment here. I'll just make these smaller. So I created a comment showing the three arguments that are needed. And you can see it on your screen now. It goes all the way across. So train range, and it tells the user what this range is. Members, the number of team members, and courses is the range of cells showing the training session names. And that makes it easier to remember exactly what order to enter your arguments in. All right, so we got the exact same results as if we did this really complex rounding and ratio formula. Here's another cool trick. So what if we wanted to find out which teams are the highest multi-skilled teams? So we have this here, but they're not in any order except for the A to Z order that's here. But what if I wanted to find out, okay, which teams are my most multi-skilled? I want them sorted by skill set ratio. I could do that here. But if I try to grab everything here, just using my sort by, it'll then take all these details, which I don't want. So here's a really cool trick. You can sort by and select the columns that you want to be displayed in your output. All right. So let's say we want to sort. We use this entire array. So from A3 to M3, right? That's the source data. What we want to include is we want to include just this column. All right. But now our filter is, we have so many columns here, most of them we don't want to see. The columns that we do want to see, we type a 1 within curly brackets here. We type a 1. So we want to see the first column, which is column A, but all these other columns, we use 0 to represent the fact that we don't want them displayed. And then the final column, the skill set ratio, we do want that one displayed. So we type a 1 here. Close our curly braces, braces, and close the parentheses here. And then it is filled. So we get the team name and the skill set ratio only. All right, that's a really cool trick. Again, we see the spill operator here. All I did, so if I delete this, that's all that's here. I just want to see an A to Z list. Remember, I already got the A to Z list in here in column, in the range A3 to A8. So I can just type equals A3. And here, and then it displays everything, right? And I have formulas to get my team stats right here. And the final thing I wanted to show you today was the implicit operator, that @ sign. Let's say we have a system in our call center where the team that has the best stats in terms of agents hitting that incentive, then that will also be the team where the team lead gets the highest incentive too. What if I didn't want to find out the entire stats? What if I just want the name? What team performed the best? Remember that all their teams have different numbers of team members, so we can't just use the total, right, that the team got. We could just say @ That's the implicit operator, which forces a single output. So even though I have a sort here, it won't do a spill. Even though sort is by default a spill, a dynamic array formula, if I do an @ before the spill, it'll only display the very first item. So I know that this team was the one that had the highest in terms of the average incentive agent to incentive ratio. And that's how that works. All right. So that's the end of the presentation. And I hope that helps. Oh, someone was telling me, I'm sorry, I had to close this because I didn't want my screen to be in the way.